Can you see
Okay.
my presentation? Yeah?
Yes, you can.
Good evening, everyone. I'm Alessandro Sabatini, Earth System and Global Changes PhD student. I will briefly illustrate my PhD project entitled Mapping the Thermophysical Properties of Apennine Rocks Implication for the Geothermal Potential. First of all, I would like to introduce myself, starting from the path that I followed before accessing the PhD course. In December 2020, I obtained a master's degree in Geological Sciences and Technologies at the University of Perugia, with a thesis entitled Determination of the Local Seismic Response with an Experimental Method of an Area near Kasha, PG, following the earthquake of 2016. I have been collaborated for about 3 years with the Andrea Bina Seismic Observatory of Perugia, with which I have carried out a third-level seismic microresonation work in municipality of Kasha, PG, published accelerometric data, and carry out other geophysical surveys. I also made a postgraduate grant with the University of Perugia on the estimation of thermophysical properties of some rocks present in the Umbria region. So despite the existence of a number of measurements of heat flow in the Earth, the temperature trend with the interior of the Earth is very uncertain. The problem is the impossibility of accessing the interior of the Earth except for low depths. Means that the temperature is derived from models strongly influenced by the thermal properties of materials. So the goal to be achieved in these 3 years of PhD course is therefore to conduct measurements and mapping of thermal conductivity of rocks present in outcrop, to measure porosity, density, and to characterize the mineralogy of the rocks, and to try to find theoretical relationships between thermophysical properties to derive relationships that are applicable everywhere. All of these could have an implication with estimating geothermal potential. Samples will be collected from characteristic formation of Umbria, Marche, and Tuscany succession, and for the measurement of porosity, properties like thermal conductivity, thermal diffusivity, specific heat density, porosity, and mineralogical composition. Porosity values can also be useful to get an indication for of the circulation of possible geothermal fluids. For the achievement of the goals are planned collaborations with the area of mineralogy of University of Perugia, with the Department of Science, Environment and Life of University of Genoa, which for years has been involved in studies and measurements of thermal conductivity, and with the Department of Chemistry, Biology and Biotechnology of University of Perugia for porosity measurements. In addition, we are involved in the community of International Heat Flow Commission, which recommends standards and techniques for determining all parameters necessary for geothermal research, including thermal properties of materials. The results can be also used to reconstruct the rheological state of the crust and connect them with seismicity, thanks to the active collaboration with the Andrea Bina Seismic Observatory. In these first 2 months of work, I began to collect bibliography to increase the knowledge relating to the thermal conductivity on different types of rocks. I collected some samples to start thermophysical properties measurements, and the research today is also focusing on investigating suitable sites for representative samples collection. I followed a course on the geology of earthquakes and a seminar on sun-earth relationship, and I am participating in the school sheet project for the orientation and enhancement of earth sciences addressed to secondary schools in central Italy, where a seismic network is being installed and for which there are general theoretical and practical lessons to students about earthquakes. Thanks for the attention.